Right, I'm going to kick it off. So, for those of you who don't know me, my name's Jeff Eggleston. I work for IBM, and I'm actually chairing the work group New Technologies. I'm actually a temporary chairman. I'm filling in for this role. This is the first one that I've started off on this agenda. Um, just some sort of house rules. I've spoken with the presenter, and we would like questions at the end. But if you'd like to put any questions now while the presenter is speaking, then by all means just raise your hand and I'll bring it to your attention. But if you need to speak, I have to unmute you on that. So the one thing I do want to remind you of is that GSE conference really thrives on feedback. So one of the things I would ask you is if you could actually give some feedback to this session. The session is AD. So if you could, that'd be very helpful. So I'm going to kick it off by first of all introducing you, Anthony Antia, who's from BMC, part of the DevOps side. I think we're very privileged and honored that he's here because it's 5 o'clock in the morning over there. So he's poor guy's been dragged out of bed to do this first presentation. So I welcome that very much. And the presentation is about modernization starts with code. So I'm going to hand the floor over to Anthony, and thank you very, very much.
Thank you very much, Jeff. And if it's any consolation to anybody, I probably would have been up about this early anyway. Maybe not quite as put together as I am right now, but still up. So thank you everybody for attending this session. As Jeff said, the title of this session is Modernization Starts with Your Code. Let me go ahead and share my screen really quick so that way you can get the presentation going and then we can go from there. Let's go ahead.
You should be able to just share it. Well done. Okay,
Yep.
Thank you, Anthony. Cheers. All yours.
Yep, so I'm assuming you guys can still see my screen.
Yep, it's both on my two screens. So yeah, I can see it. So thank you very much.
There we go. All right, well, we'll go ahead and get started. So modernization starts with your code. So this is going to be a session about modernizing your code base or refactoring your code base. So let me go ahead and jump right into it since we're not getting a late start, but we're not getting an early start either. So first things first, a little bit about me. So from 2014 to 2021, excuse me, I was the director of engineering for CI/CD at American Express. As such, I had the responsibility for all of the DevOps tooling, operations, and the entire platform for the company. This included both the distributed side, where I'm actually from. So I'm not a typical mainframe developer. I am from the distributed side of the house, but this started with the distributed side of the house and then eventually moved into the mainframe side when the company came to me and said they needed to bring automation and DevOps onto the mainframe. So at that point, I was tasked with bringing DevOps onto the mainframe platform. And we partnered, at the time I partnered with BMC, excuse me. At the time I partnered with CompuWare, later BMC Software, to bring in Agile DevOps tooling and hook that into our mainframe. And the scope of this project was around 500 applications and 3,500 engineers that we moved off of the legacy platform that we had onto the new DevOps platform that we created along with BMC. As such, I noticed some things as we went along and we were talking about transforming, right? So we migrated our code off of our legacy platform and into code pipeline, used to be called ISPW. And we hooked it up to agile processes, and we transformed our teams into agile teams with automation and end-to-end pipelines that moved them from dev to production. And it was great. But there were also some, as we went along, there were also some issues that began to creep up. There were some issues that began to happen. And most of that had to do not with the automation, not with the tooling, not with anything that we did. It was mainly the code base, right? For years, Amex had been practicing a waterfall development methodology. For years, Amex had been piling code on top of code on top of code into gigantic monolithic programs that were racking up technical debt because no one had gone back and gone through and looked at the practice of refactoring their code. So I mean, what was the actual issue, right? The issue was that application teams and applications in general, the idea was that the issue was, well, we're on a legacy code base, we're on COBOL, we're on a code that doesn't scale itself well, or that can't move to a different platform. And the reality was the problem was not COBOL, right? The problem was in the way these applications were architected, in the way these applications were put together. The issue was they needed to be redone. They needed to be refactored. They needed to be changed in order to make the most efficient use of the automation that it had, right? There isn't really anything wrong with COBOL, right? These applications ran perfectly fine. They had all of the business logic built into their systems, and they had all the business logic that they need. The business had already signed off on, right? To survive and provide value, these applications needed to be modernized. They needed to be maintained and extended. And I would say that this is the case with a lot of different mainframe teams and mainframe organizations that I go into and consult with. A lot of them have applications that haven't really been re-architected or reorganized in probably 20 years, 25 years, 30 years. And a lot of the people that knew the inner workings of the architectures of these applications have left. They've gone, they've retired, they're no longer there, right? So in order to do that, right, in order to make these applications vibrant again, you absolutely have to go in and you have to reorganize them and change them, right? Changes are needed, but developers are hesitant to make the changes, right? Because the developers the true SMEs on these applications are gone. And as you bring in a new guard of application developers into these applications, it's hard to get them up to speed, right? Add to that with these giant monolithic applications and giant monolithic code bases, mainframe development can be slow, which frustrates the business, which means that changes now take longer and longer and longer to do as you pile up technical debt within these applications, right? And these aren't, without updating these architectures, you're not going to get that. You're not going to be able to make quick and agile changes. You have to break these down into smaller pieces, right? So why are these monoliths such a problem? Why are these monoliths an issue? Again, going back to what I said before, the problem isn't COBOL. The problem problem isn't the language. COBOL is just another language, like Java, like Go, like Node, like any other programming language. It's not the language itself, it's what we've done with it, right? COBOL programs are built with a lot of distinct functions, but what they've done is now they've piled all those functions into a single monolithic program. So now you have programs that are 100,000 lines, 200,000 lines. The biggest one I've ever seen is 650,000 lines of COBOL code. And I'm not talking about a program deep in the application that hasn't been touched for 30 years. I'm talking about an active program that people are continually checking out, modifying, and then checking back in. 650,000 lines of code, right? All of which have to be modified, checked out. You have to find the right spot for where you're going to do your changes, checked out and moved, right? This slows things down. This makes your application development much slower and much harder than it needs to be. So how does it slow this down, right? Think about this. If I have 200,000-300,000 lines of code, how hard is it to understand the logic of that application? How do I understand the logic of the module that I'm looking at? How do I know exactly where I need to make any changes? Even if I'm an experienced COBOL programmer who possibly knows COBOL backwards and forwards, it's still harder to look at the logic of this application. Excuse me. Look at the logic of this application, look at what it's supposed to be doing, the business rules, how it can be done, what can be done with it, and then where to make those changes, right? It's also very hard to have parallel development going on with these large applications. Merging can become a challenge as you get more and more and more people. If all of your logic is in one central place and everybody has to check that single module out to do 80% of the changes, you're having constant merge problems, constant issues with that. Last, it's difficult to text all of it, right? If I have 200,000, 300,000, 400,000 lines of code, am I able to write solid unit tests? Am I able to write tests that can test all of the functionality and all the capabilities within that module? All of these become a nightmare when you're dealing with a large monolithic program. So let's take a look at an illustration of that. So I'm sure everyone has a different SDLC or a different life cycle for their program. So this is just a mock-up of a typical sort of happy path SDLC that I've seen when I go and I work with organizations on how to reorganize and how to modernize their mainframe. But if you take a look at it, Team A has a large monolithic program that they need to deal with. So let's say, going back to this, right? You have different capabilities built into this one single monolithic program. Account creation, calculate your balance, account balance updates, update customer records for a bank or a financial institution, right? So now if I want to make a change to, let's say, the account creation portion, I have to check out that entire program, right? Now, let's say at the same time, there's another person on the team that needs to make a change to the update the customer record capabilities, customer record function inside of that module. We both have to check out the entire program, right? We have to review the entire program to make changes to that program. Now, let's say maybe both of us have worked in this code base a long time. So, all right, maybe I'm able to semi-quickly able to find that where to make those changes and how they work. But both of us need to do that. We then need to build the entire program and then test the entire program. And all of this is before we've even merged our changes back together. At some point, we're going to have to merge those changes back together. And then again, test the entire program. Each and every time I want to make a change, each and every time I want to make any kind of modifications to this, I have to pull the entire program down and do modifications to it as it is. This is carrying around extra baggage. This is carrying around extra weight that I shouldn't necessarily need to do, right? As I'm going along, if this had been broken down, then I would have different capabilities. So let's take a look at what that would look like, right? So what is refactoring? I've mentioned that a couple of times. What is refactoring? So refactoring is improving your code's internal structure by making small iterative changes without changing the external functionality of your code. So if my code is a banking application and it has, the account creation and calculate balance and all those capabilities built into it, I'm not changing those external capabilities. Someone is still going to call the program or call my application for account creation, and I'm still going to create an account. So none of those signatures in or out are changing, nor is the functionality changing. But refactoring is the practice of going in and making small changes to my code base and how it works in order to modularize it, in order to make it better, in order to make small iterative changes to make the architecture of my application a little bit better. Now, you can look up refactoring on Google and you can get 100 different definitions, but they all lead to roughly that same place. So what would that look like, right? So let's say I took my program and now I broke it out into separate modules. Okay. I took that main logic that you saw in the previous couple of slides, and now I broke that out into account creation would be a separate module. Calculate balance would be a separate module. Account balance updates would be a separate module. Update your customer record would be a separate module. Now I've taken that giant monolithic program and broken it out into smaller components based off functionality. Now a developer can update the account creation subprogram without having to check out the entire program. Using that same previous example, another developer can do changes to the update customer record without having to check out the entire program. Now, my program hasn't changed. The functionality of my program hasn't changed, but now I've broken that program down into multiple pieces. So let's take a look at that same life cycle that we just saw a minute ago and see what it looks like. So if I haven't refactored my code, my process is the same, what we reviewed a little bit ago, right? I'm having to pull down the entire program, whether I want to only make changes to account creation or update customer record. Doesn't matter which one. I'm pulling the entire program down, having to review it, build it, and test it, right? But if I have refactored my code and I have broken that code down into smaller chunks, smaller pieces, then at that point, I am able to check out the single module where I'm trying to make my change. So let's say again, it's account creation. Now I have less code to review and less jungle to cut through, for lack of a better term, to find where I'm going to make my changes. Now I can build that sub-program in isolation from the rest of the logic of the application. And it's a lot easier to create smaller unit tests for those applications, right? For those sub-modules. By refactoring my code, I've simplified my process greatly. Now, I still have to go through and do the work. I still have to understand the logic of my program. I still have to understand all those capabilities about my application. But now I've made my code base a lot smaller and a lot easier to deal with. Now I'm only dealing with the logic I need to deal with versus having to take the entire program and do that. So how do you go about refactoring, right? How do you go about refactoring and doing the, using these capabilities and breaking this down? So there's a few different techniques. So I'm not trying to reinvent the wheel. These are some standard refactoring techniques that you can use to do this. Now, I think one of these really applies to the mainframe more than not. We'll get into that in a second. But so refactoring techniques, so red-green refactor, right? So this is really tied to application development if you're doing a test-driven design kind of pattern for your agile development, right? So TDD is basically I create a test. That test fails based on the logic that I want to put into my application. Then I write the code to make that test turn green. That's that's quote unquote test driven design, or the red green portion. The refactoring portion of this is now I refactor my code within that TDD design in order to make sure that my tests stay green. So it's following a TDD design pattern, but then you're actually sitting there and making sure that your tests stay green. So it's a way of making sure that your refactor doesn't have any issues with your application. Another technique is abstraction. So this is an object-oriented technique where you identify common functionality that's used in multiple places or by multiple modules, and remove it into a common callable abstract component. I know there's object-oriented COBOL because we're specifically talking about COBOL, but abstraction is more for more object-oriented programs. But you could use this same technique by taking common or duplicate code within your application and making it callable modules, right? So it doesn't have to be a pure OO technique, although if you read about this one online, it's going to give you a lot more of the object-oriented principles than not. But a way to apply it to an older code base written in COBOL is doing exactly that. Identify those components within your application that are common modules, common capabilities. Hey, every time I calculate my account balance, I calculate it the same way, and make that a common callable module, common callable function, so that I'm reusing that instead of rewriting that. Extraction is really what we've been talking about. Well, let me go one further. So preparatory refactoring. Preparatory refactoring is really just a way of saying that I'm going to go in and I'm going to make a change. I'm going to add a new module to my program. Let's say account lookup. And now I know I'm going to make that. So I'm going in, and as part of preparing to make that, I'm refactoring my code to make it easier to add that module in. So it's really not in and of itself a new technique for refactoring, but it's listed if you do a search on different ways to refactor your code. This is one of the ones that comes out. I think the one that applies most to older code bases written in COBOL, quote unquote, written in COBOL per se, is extraction. And again, that's breaking down your large monoliths into smaller, more manageable components. And this gives you a bunch of different factors. Again, it allows you to organize your code base a lot better. It makes it a lot easier and a lot more functional to understand what's going on in your code base and where, instead of having, module 1, 2, 3, 4, 5, 6, 7, and written somewhere in the hundreds of thousands of lines of that code as a function that handles account creation. If I have a module called account creation that is sitting there and is its own set of capabilities, then at that point, that account creation module becomes that account creation module now becomes its own piece of functionality, and it becomes a lot easier to understand where to go, right? The other thing it does is it allows you to streamline your code base. By making these callable functions, it's a lot easier. And the last thing you need to think about when you're talking about refactoring your code or modernizing, and I almost hate that term because there's nothing, the mainframe is incredibly modern, right? There's nothing wrong with the mainframe in and of itself. There's nothing to modernize. It's really the application architectures that need to modernize. But that said, the next piece, the next benefit to that is for that next generation that's coming in. I know all of us have seen all of us have seen the system. All of us have seen these statistics. All of us have seen people start retiring. All of us have seen people start to leave, and a new generation is coming in. That new generation hasn't spent 25 years in this code base, and it's going to be very hard for them to come up to speed and learn the new capabilities, learn this new application as they come in. By breaking these down and by refactoring your code and cleaning it up, you're providing them an ability to come in and onboard more quickly, be functional more quickly, be able to come up to speed more quickly. And the last thing you're doing here is paying down technical debt, right? You're paying down technical debt so that as I go on in the future, I'm not having as much of a problem to build that up. So what are some best practices if I want to go through and I want to refactor my code? So the first thing you need to do is you need to plan. Well, let me go back and say one more thing. Which one of these is the best way to refactor your code? There is no best way, right? These are common techniques and these are patterns that you can use to do it. But the reality of it is, it doesn't matter which one of these that you practice or which one of these that you do. There is no one that's better than the other. Just like we've all learned from being in engineering for however many years you've been in it at this point. There's 100 ways to skin the cat. And you have to pick the most efficient and the best way to skin the cat for you, for your application, for your organization, for your team, for however you want to do it, and pick that and go forward with it. So it doesn't matter which one of these techniques you practice. It just matters that you're taking the time and energy to go through and modernize and update your code, because it will benefit you. It will benefit the next guy who has to come in and make a change, and it will benefit your organization as a whole. So refactoring best practices, right? So what are some excuse me, things you need to do to tackle refactoring of your code base? The first thing you need to do is plan, right? This is the same as any other project you're going to work on, any other code base change, any other capability that you're looking to do, any other capability that you're looking to take on. You need to have a plan. You need to have an architecture. You need to have a thought. So you need to take the time to plan out your changes and what the scope of those changes can be. The second thing you need to do is iterate. Agile is about small iterative changes, and so is refactoring. You don't want to take your entire application and break it up into 16 pieces all at once and push all of that change into production tomorrow, right? You want to start small. You want to start with small iterative changes that you can do to make incremental change or incremental improvement to your code base. And that is exactly what refactoring is about. It's not about going in and slicing the cake into 100 slices. It's about taking one slice at a time and serving it up. Along with iterating, you want to focus on quick wins, right? You want to focus on those things that are easy places to start that will incrementally improve your code base. Two of the big ones are dead code and duplicate code. Right? I see a lot of teams that go through and refactor their code. And what they do is they start by removing dead code. They search out and find dead code in their code base. And we'll talk a little bit about how to identify that in a minute. But they start by removing dead code, dead modules, places or capabilities that are no longer used. And those are the ones they remove. Same thing with duplicate code. They identify those places where you have duplicate functionality. And again, you break those out into callable functions or callable modules and use those to make them a common piece of functionality. And you'd be amazed at how often you find that, because no one really has a good mapping or a good understanding of the code base as a whole, because it's so large. You're going to find there's a lot of duplicate code. So just removing those things can streamline your application greatly. You need to have the ability, or you need to take the time to analyze your code base. Make sure you understand your code and the ramifications of the changes that you're going to make. Right? So there are some things that you can do to do that as well. We'll talk about those in a second. But you need to take the time to analyze your code, and analyzing your code also includes your data, how your code works, what your data techniques are, all of that. You would be surprised as to how many application teams that I've talked to that don't have a great understanding of their code base as a whole. They don't have a great understanding of how their code works, what data it uses, what their data schema looks like, how all of the pieces fit together. You need to make sure and analyze those capabilities and techniques. Analyze your code base, how your modules work, how everything fits together, so that you understand if I'm breaking X out, or I'm breaking Y out, or I'm breaking Z out, or I'm removing this dead code, what's the effect to the overall application. And it's also going to be very hard to identify dead code and duplicate code without having something to be able to do that analysis. You need to have good testing. If you're going to go down the refactoring route, then one of the things you're going to need to do is be able to make sure that if I've refactored this code, that I haven't broken anything. Now, theoretically, you shouldn't break anything. That's not the point of refactoring, because you're not actually changing any of the modules, or you're not actually changing the functionality. But anytime you're moving code around and you're sort of re-architecting things, you need to make sure that everything stays the same, which goes back to that red-green refactoring. Even if you don't practice that, you need to make sure you have good tests, preferably automated tests that you can run quickly and easily in your local environment, like a unit testing, in order to make sure you haven't broken anything. But you need that testing, and you need that solid testing to make sure you have a good set of tests defined to validate your refactored code. The last thing is you need to prioritize. This should be a priority part of each one of your sprints. Now, the business is going to come in, the business is going to have new functionality, and the business is not going to care about whether you've refactored your code or not. Now, there are some things you can bring up with your business to talk about that, but again, that's something we'll discuss here in a little bit. But this needs to become a priority or a standard practice each and every sprint. Again, you're iterating through this and you're focusing on small iterative changes. So you don't need to take your entire sprint and dedicate it to nothing but refactoring. But there should be a certain amount of stories, a certain amount of story points that you go through each and every sprint in order to make sure that you're prioritizing refactoring and prioritizing making your code base better. And you need to build this in and talk to your business about why. Why do you do this? Again, we'll We'll get onto that in just a minute. So refactoring versus rewriting. So a lot of times when I talk about refactoring and I talk to customers about refactoring, I talk to customers about, refactoring their code, I get this question asked, right? Refactoring or rewriting. Which one should I do? Which one should I practice? And again, just like the previous slide, there is no right or wrong answer to this question. This is something that you have to do, and you have to take a look at that. Now, what are some of the benefits of refactoring, right? Versus rewriting. Number one is refactoring is a lot less time and cost in actually doing it. You're not actually taking your code base and sort of breaking it all down. I'm going to say throwing it away, but don't take that as literally as it sounds, and rewriting it in a new language, right? I'm taking the existing code base, code that works, and I'm re-architecting it to make it smoother and more efficient, theoretically more efficient, at least more efficient from a development point of view, right? So it's going to use existing working code that is there. I know all of my business functionality is there. I know if I go to create my account balance or update my address, all those capabilities work, right? You also maintain the advantages of the platform. When I talk to people about refactoring or redoing their code, a lot of them are saying, well, we're getting off the mainframe. I'm going to be off the mainframe in 4 years. I'm going to be off the mainframe in 2 years. I'm going to be off the mainframe in 5 years. The reality of that is, number one, a lot of those projects run years and years and years longer than were planned. I'll give you an example. When I was at American Express, although I wasn't on the mainframe platform, there were major initiatives going on when I walked in the door where they were going to re-architect the mainframe applications and move them into the cloud, move them into the distributed platforms. And, the plan was 3 years from the date I walked in, we're going to be off the mainframe. Fast forward 3 years, and not a single load had moved off the mainframe. Not a single application had been redone. Nothing had changed. Even though these projects were ongoing projects with active work being done, nothing had come off the mainframe. So then another 3 years after that, okay, we're going to be off the mainframe. Everything's going to be good. We're going to be done, where this application is going to move to the cloud, yada, yada, yada. Fast forward another 3 years. Again, nothing had moved off the mainframe. When I walked out the door, not a single thing or load had been moved off the mainframe. The reality of it was that what they discovered was, can I re-architect this application? Maybe. Can I get the throughput and security and power, especially in my batch and system of record, my data, that I can on the mainframe? No. No one had been able to do that up to this point. So I'm not here to talk about getting off the mainframe versus not. That's a conversation for another day. But by refactoring, you're maintaining the advantages of the platform, and you're not introducing as much risk by rewriting this. Now, the one thing I won't say about refactoring is it doesn't improve the overall quality of the code. And what do I mean by that? Because refactoring will make your code base better, will make your code base more organized. But if I have a horribly written COBOL function and I now refactor that to its own module, it's still a horribly written COBOL function, right? This isn't a magic wand that's just going to improve your code base and make your code base better. It's not a panacea. Bad code will be bad code. So you do need to take time in refactoring that portion of your code, rewriting it to make it more efficient, better, but not necessarily in a new language. Rewriting has its own set of challenges and advantages. You time and costs will increase. You know, you have to translate those business rules out of your previous code base into the new one. And just like we said with refactoring or with making changes in general, the people who wrote that are most likely gone at this point. So having to extract those business rules can take time and cycles. You're redeveloping features and capabilities that are already there and are already working. And you're probably going to have to align that with your business. Refactoring, you really don't have to align that with your business outside of agreeing that you're going to make it a priority and take a certain amount of your time to do it. But with rewriting, you're going to have to align that with your business and probably involve them in the testing. The other thing is there are a lot of tools out there that will take your old code, quote unquote old code, your COBOL code, and attempt to convert it into Java or Go or some Python or whatever modern language that it does. And I'll be honest with you, I've seen very spotty results with that. I've seen a lot of applications and teams and organizations go down this route, and you take spotty COBOL and you run it through a tool and you get even worse Java on the opposite end. Very unreadable, very hard to do anything with, very hard to understand, and it doesn't always get it right. Now, maybe there's a tool out there or there's a tool in development that will make that better. That's a distinct possibility. I have yet to see one. So from my personal experience, those kind of things really don't work out well. So I think that you have some refactoring isn't the cure to all, but I think it's a good technique. Rewriting has some challenges to it, but again, you have to determine which one is best for your organization and for your capability. I think the biggest thing is don't try to take this on all by yourself, right? Refactoring it's straightforward to think about, but it's not it's not easy even if you have in-depth knowledge of your application code base, right? Even if you have in-depth knowledge of what your code does, where are all the pieces, where are all the skeletons buried, it's not something that you can just sit down and go, okay, now I've broken everything down. You need to have a plan and a design and a scope, but don't try to handle it alone. There are a lot of different automated tools and capabilities that can help you do this. I'm not here to do a proselytize anything. There are linters, so you can basically do lint scans at your local, in your local work environment. Static code analyzers like SonarQube, capabilities like that. And you have built-in refactoring capabilities that are built directly into your IDE. BMC software that I work for, we have a capability called Code Insights, which basically maps out your source code, shows you all the different pieces and parts and things that you need to do how your application code is built, and then gives you the capability to extract parts of your code and create separate callable modules from those. Sort of handles it for you. I know IBM has some similar capabilities. I'm not as familiar with Broadcom offerings in this area, but there are a lot, and there are probably 500 open source capabilities that are out there. What you need to do is you need to figure out what you want to do, plan it out, like I said, and then look at the different tooling and figure out what works best with you. The last piece I have there is let the knife do the work. And that's something, if you've ever heard me speak before, that's something I say a lot when we're talking about tooling. And what I mean by that is at home, I really like to watch those Gordon Ramsay cooking shows. I don't know what that says about me, but I really like to watch cooking shows. And I was watching Gordon Ramsay break down a fish. And he was showing how, you cut the fish and debone it and do all its pieces. And there's a part where he gets it's a piece of salmon. He lays it down and he's going to cut the skin off. So he goes through and he makes a quick incision and he starts sliding the knife down. And what he says is, let the knife do the work, right? Don't hack at the fish and start chopping at it and whatever. He goes, just get it in there nice and smooth and run it through and let the knife do the work. Let the knife do the cutting. And I think that applies to what we're talking about here. Use these tools, use the capabilities that you have natively at your organization, as well as what tools you have, and let them do the work for you. Get something that can handle it, like Code Insights. Get something that can map it out and extract it and help you refactor your code. And let that tool help you do that extracting. The last thing I want to say is get your business involved. Get your business involved in acknowledging that refactoring is a net benefit. So one of the techniques when you go down these kind of projects is you need to get your business involved and have them understand why you're doing this. This isn't just about going in and doing engineering for engineering's sake. This is making your code base easier and better so that then you can get more changes through the pipeline. By making your code base simpler, it'll be a lot faster. Now when they have that new functionality or that new capability they want to launch, that makes your code base better. If you get your business involved early and you get your business understanding why you built code refactoring into your overall sprint, then that's just going to make this process go better and better and better. Thank you very much. I'm good with any questions now. If anybody has any questions or thoughts, or you just want to tell me this was the worst 45 minutes of your life, that's fine too. I'm open to all feedback, like Jeff said.
Tony, I don't think you should undersell yourself. I thought it was a fantastic presentation. So
Thank you.
I particularly like your description of nightmare. One thing I didn't share with you was I used to teach COBOL back in the 80s, and we had a lot of COBOL code of one of the companies that we talked about. So it kind of brought memories. And I do like one of you saying, a couple of your sayings were sort of like small iterative changes for quick wins. But the one thing that I was eager to find out, and I'm sorry if I missed it, but I don't think I got it. And you talked about dead code and duplicate code. And you said there is a way of identifying dead code. I was waiting for that. I don't know if I missed it.
Sorry.
Waiting. Would you
Yeah,
would you
I did.
put me
I did
put me
sort
out
of
my
tease.
misery and tell me how you do it?
Yeah, so I did tease that. Sorry, Jeff, and I didn't follow through or didn't tie the knots together. When you're talking about using automated tools, so any of your standard linters, so if you're using like doing linting with SonarQube, just to use it because it's the one I'm the most familiar with, that will allow you to go through and scan, and it will help you identify dead code um and or code smells, right? So
Right.
using code smells, you can go in and identify, okay, how much of my code is good, how much of my code is bad, what is dead, and then from there you can identify that. Same thing with SonarQube. If you want to get more in depth and not have to dig through it as much, I can tell you from a BMC point of view, like I said, we have a tool called Code Insights, and one of the capabilities that it has in it is to specifically identify dead code. So you can go through, and when you're doing your mapping or your searching of the code through the analysis portion of it, it will identify dead code, as well as it will you can do a search when you go to do the extraction portion. It will actually go through and remove dead code for you. So it will actually identify that dead code as part of the extraction and remove it for you. And then the last piece of that, if you have any runtime capabilities and you're looking at your code coverage metrics, that's another really good way to identify dead code. So if I'm going through and I have a good set of automated tests that I'm running, and then I'm looking at my coverage, if I'm seeing I'm only ever getting 85%, then most likely you have some dead code and you need to go through and sort of, as part of a runtime visualization, look through
Right.
that code and see what's being executed and what's not, and identify it as dead code. So those are 3 or 4 different ways you can go through and you can find that dead code. That would actually be a really good session to just, if you allowed demos to go through and show some of those different techniques for finding dead and duplicate code.
Yeah, I totally agree with you, and thank you for sharing that. But there was a big anticipation there, so I thought it was me for a moment, but there we go.
No, it wasn't. Sorry, I should have tied that together better. I apologize.
No, it was fantastic. Don't worry. There are still some participants on. Anybody got any more questions? Please. We've got a couple of minutes left, so if you've got any more questions, please raise your hand and I'll unmute you. I'll give it a minute or two. While we're doing that, Tony, could you put the feedback foil
Oh,
up,
yes,
if
here
you
you
don't
go.
mind, please? So again, as I introduced the session, GSE works on feedback. So please, if you could actually give feedback. The section is AD, and there's the code, but you can actually go on and onto the GSE webpage and actually leave the feedback. The one thing I didn't mention is Tony's presentation is not on the agenda yet. And I'm going to put some words in Tony's mouth here. He assures me that it's going to be there when we actually close the session. But on a serious note, Tony, if you've got any problems, then just give us a shout.
Absolutely, I will. And I thank you, Jeff. Thanks everybody who attended. I really appreciate the chance to talk about this. It's one of those topics that I think as engineers we don't talk about enough, and it's one of the things I'm sort of passionate about. And so I appreciate everybody coming and listening to me, and hopefully you got something out of this and you take that back and use it. I'll be uploading the deck onto the GSE site as soon as I get done today.
Okay, so lastly, I'm going to say thank you very much. I'm conscious what time of day it is. Your neck of the woods, it'll be coming up to 6:30 now. So go and get that coffee and what have you. So I'm going to bring this to a close by ending the meeting. And thank you for all the participants. And Anthony, once again, thank you very much. Really appreciate it.
Absolutely.
Have a good day.
Thank you, Jeff.
Cheers.
Thank you.